Okay, welcome back to our videos on coding. In the last one we looked at the mean and standard deviation, and this time we're going to kick off with correlation. And just to refresh your memories, I'd like you to just pause the video and have a go at calculating the product moment correlation coefficient for x and y for this set of data. Okay, hopefully you've all had a go at that. 0.655 I got to three significant figures, so bear that in mind, make a note of that. And now we're going to have a look at what might happen if we apply some coding. Now here's the codings that we're going to use. The x values, we're going to use this formula to convert them to p values, and the y values, we're going to use this coding to convert them to q values. And these are the p values that we get, and these are the q values that we get. And here's the data that we'll need to calculate the product moment correlation coefficient for p and q. So you've got p squared, q squared, and pq, and then all the sums at the bottom. And if we just scroll a bit further down, we can see what happens if we calculate SPP, SQQ, and SPQ. And for R, we're doing this one divided by the square root of this one times this one. And okay, what have we got? 0.655. It's exactly the same. The coding has made no difference whatsoever to the product moment correlation coefficient. So that's a really crucial point, and you will need to spot that in exams, and you'll be tested to see if you can spot that. Here's an example of an exam question testing correlation coefficient, and you'll see in part A you're given some data, you're given some summary statistics here in part A, so you don't need to work all of these out, but part A is just asking you to calculate the product moment correlation coefficient, and it's giving you some of the summary statistics. There's just a couple of marks on offer for calculating R in this case. Part B, you'll need to do some kind of interpretation, so linking what's actually going on with the attendance and the goals scored, make some kind of interpretation in the context of the question. Just a mark again for that one. Now I'd like to have a look at part C. It says she decided to divide the attendance figures by 100 and then calculated the product moment correlation coefficient between x over 100 and y. Now it doesn't specifically tell you that this is a coding, so you need to spot that there's some coding going on here. And then it says write down the value that Helen should have obtained, and that's just one mark. So the clues here, write down. The question just says write down, and it gives you one mark. That means you shouldn't really be doing any complicated calculations, and it's just going to be exactly the same as your answer in part A. Product moment correlation coefficient in part A is exactly the same as that in part C. So you're just going to write down the same answer for part A. You're going to write that down in part C, because the coding here makes no impact at all on the correlation coefficient. Okay, that's nice and easy. Regression, a little bit more complicated. Let's have a look at what we might need to deal with for regression if we can use coding. So let's say we're given some regression. A regression line of D on C is worked out using this coding, and we're given some summary statistics for x and y. We're given the mean of x bar, and the y bar, and you're asked to calculate the regression line y on x. Now you can do that using the summary statistics given to you in part A, and then part B says find the regression line of D on C, so that's where the coding's coming into it. Let's just have a look at part A. So in your regression line you need to work out the values of A and B. So B is just 120 divided by 240 from the summary statistics, and A is the mean of y, subtract B times the mean of x. So we've got our values for B and A, and then you plug that into the regression line for y on x, and you get y equals 3.5 plus 0.5 x, that's the regression line for y and x. Now, with the coding in part B, what we can do is substitute into the equation for the regression line, because we've got these formulas and we can use these as substitutions, because we know that x equals c over 2, so we can just, instead of writing x, we can just write c over 2 here, and instead of writing y, we can write d over 10. And if we do that, we get this equation here, and we need to tidy it up a little bit, rearrange, and what I've done here is just multiply through by 10, so we get d equals 35 plus 2.5c, and that's it. That's our regression line for d on c. And that's it. Now, if you've watched the first video as well on coding, here's a summary of the 4 things that we've looked at. So for the mean, if you're finding the mean of the coded data, what you can do is undo the coding by reversing the operations, and that will give you the mean of the original data set. We also looked at standard deviation, and the key thing here is that it's only the multiplication or the division within the codings that have any impact on the standard deviation. So those are the only ones you need to undo when you're reversing it. And you can ignore additions or subtractions because they have no effect on the standard deviation at all. You're just shifting all the data up or down, makes no impact on the standard deviation. With the correlation, coding has no effect on the correlation coefficient at all. And with regression, you can substitute the coding formula into the regression equation. So there we go. There's how we can use coding to find mean, standard deviation, correlation, and regression.